Hello there, and welcome to Whispers of Science, where curiosity drifts gently through the clouds and knowledge falls like gentle rain. Tonight, we're following one of nature's most humble yet extraordinary travelers on an epic journey that spans the heavens and the earth. The simple raindrop. It begins as invisible vapor, rises through towering clouds, and eventually finds its way to your window pane. But oh, what stories it could tell along the way. Before we begin this watery voyage through the atmosphere, I'd love to know where in the world you're listening from tonight. And is it raining where you are? How fitting would that be? A video about raindrops, while drops are tapping softly against your window. If you find this gentle journey through the water cycle soothing or perhaps educational in its O's in dreamy way, I'd be ever so grateful if you gave the video a like, subscribed to this cozy corner of science, or simply let me know in the comments what weather is greeting you tonight. Now, I do hope this isn't so fascinating that it keeps you awake, but if it does well, at least you'll have learned something beautiful about the intricate dance of water in our atmosphere. So settle in, take a deep breath, and let's follow our little raindrop from its very first moments as invisible vapor to its eventual splash landing, because somewhere between evaporation and precipitation lies one of the most elegant stories nature has to tell. Our story begins not with a drop at all, but with something far more subtle, water vapor invisible, weightless, and everywhere around us right now. As you breathe, molecules of water are floating through the air, having escaped from oceans, lakes, rivers, and even the morning dew on grass. Each molecule a tiny refugee from the liquid world below, dancing freely through the atmosphere. This is where our raindrop's journey truly starts, in the warm embrace of the sun, somewhere perhaps above a quiet lake or a vast ocean. The sun's energy strikes the surface of the water and performs its ancient magic evaporation, molecule by molecule water, escapes its liquid bonds, and rises into the air like countless invisible balloons, each one carrying just a whisper of the lake or sea from which it came. But here's where the story gets interesting. Our water vapor doesn't simply float aimlessly through the sky. It begins to rise, carried upward by currents of warm air like an elevator made of wind as it climbs higher and higher. Something remarkable starts to happen. The air grows colder with each meter of altitude, and our water vapor begins to feel the chill. You see, the atmosphere has layers, and as our vapor ascends, it enters regions where the temperature drops steadily, about 2 degrees Celsius for every 1,000 feet of elevation. It's like climbing an invisible mountain where each step takes you into increasingly frigid air. Now, here's where physics becomes poetry. As the water vapor rises and cools, it reaches what scientists call the dew point, that magical temperature, where the air becomes saturated with moisture, unable to hold any more water in its gaseous form. Think of it like a sponge that's absorbed all the water it possibly can, one more drop, and everything starts to overflow. When our water vapor reaches this point, it begins to look for something to cling to, and this is where the story takes an unexpected turn, because water vapor is surprisingly picky about what it condenses onto. It can't just become a droplet anywhere. It needs what scientists call condensation nuclei, so it's tiny particles floating in the atmosphere that serve as the perfect landing spots for our vapor to begin its transformation back into liquid form. So, these condensation nuclei are everywhere. Microscopic specks of dust pollen salt crystals from ocean spray, tiny fragments of meteorites that have burned up in our atmosphere, even particles from volcanic eruptions half a world away, each one a potential birthplace for our raindrop. Without these tiny hitchhikers, our water vapor would remain stubbornly gaseous, even in very cold conditions. It's one of nature's little requirements that water needs something to hold on to when it decides to change from gas back to liquid, like needing a friend to help you move to a new home. Our water vapor finds its perfect particle, perhaps a grain of sea salt that began its journey from ocean waves crashing against distant shores, or maybe a speck of dust that once rested on a mountain peak somewhere far below. And in that moment of contact, something beautiful happens. The invisible becomes visible as our water vapor begins to wrap itself around this tiny nucleus, forming the very first hint of what will become our raindrop. But we're not done yet, because one water molecule doesn't make a raindrop any more than one note makes a symphony. Our newly formed droplet is still incredibly small, about 1/100th the width of a human hair, practically microscopic, and it's floating in a cloud alongside billions upon billions of other droplets, each one born in the same way, each one clinging to its own tiny nucleus. This is the birth of a cloud, the magnificent floating city of water droplets suspended in the sky like a aerial neighborhood where our raindrop begins its community life. Inside this cloud, something fascinating is happening. The droplets are growing, but not in the way you might expect. They're not simply absorbing more water vapor, like tiny sponges. Instead, they're playing an elaborate game of collision and merger. Imagine a cosmic dance where droplets bump into each other, and when they do, they sometimes stick together, forming larger and larger drops. It's like a slow motion game of pool where every collision creates a bigger ball. Our little droplet starts small, but through countless encounters with its neighbors, it begins to grow. The physics of this process is surprisingly complex. Larger droplets fall slightly faster than smaller ones because they're heavier, so they catch up with the smaller droplets below them, and when they collide, they merge, creating an even larger droplet that falls even faster. It's a snowball effect, quite literally in some cases, where our droplet becomes a collector gathering smaller droplets as it moves through the cloud like a tiny vacuum cleaner made of water. Meanwhile, the cloud itself is alive with motion. Air currents called updrafts are constantly pushing droplets higher while gravity is trying to pull them down. It's a constant battle between the upward force of rising air and the downward pull of gravity, and for a while the updrafts win. Our growing droplet gets carried up and down through the cloud like a passenger on an invisible roller coaster, sometimes rising to heights where the air is so cold that it might briefly freeze into ice before melting again as it descends back into warmer regions. This vertical journey through the cloud is crucial to our raindrops' development because each trip up and down gives it more opportunities to collide with other droplets to grow larger and heavier. With each cycle, it becomes more substantial, more real, more ready for the next phase of its journey. And all the while, the cloud around it is constantly changing. New droplets are forming while others are merging. The whole system is in constant flux, like a city where buildings are constantly being built, torn down, and rebuilt. But there comes a moment in every raindrop's life when it reaches a critical size, when it becomes too heavy for the updrafts to carry it any higher, when gravity finally wins the tug of war. This moment varies depending on the strength of the air currents, the temperature, and the size of the droplet, but typically it happens when our raindrop reaches about 2 to 5 millimeters in diameter. Suddenly, it's no longer a cloud citizen floating freely through the sky. Instead, it becomes a traveler beginning its descent toward the earth below. And what a descent it is! Our raindrop doesn't simply fall straight down like a stone. Instead, it begins a complex dance with the air around it as it falls. It encounters air resistance, which shapes it into a distinctive form. Not the teardrop shape you might imagine from cartoons, but something more like a tiny hamburger bun flattened on the bottom by the pressure of the air. It's pushing through. This shape actually helps it fall more efficiently, cutting through the air like a natural parachute designed by millions of years of physics. The speed at which our raindrop falls depends on its size. Smaller droplets fall slowly at perhaps 1 or 2 meters per second, while larger drops can reach speeds of up to 9 meters per second. But even the fastest raindrops are surprisingly leisurely travelers, taking several minutes to complete their journey from cloud to ground. During this descent, our raindrop continues to change. It might collide with other falling droplets, growing even larger, or it might encounter areas of different humidity, causing it to shrink slightly as some of its water evaporates back into the atmosphere. As it falls, our raindrop also becomes a tiny time capsule, carrying with it traces of its journey through the atmosphere. The condensation nucleus at its heart might be a fragment of desert dust that traveled thousands of miles or a particle of soot from a distant forest fire. The water molecules themselves might have originated from an ocean on the other side of the planet or from a small pond in someone's backyard. Each raindrop is thus a collection of stories, a gathering of water that has traveled the world before coming together in this moment of descent. And as our raindrop continues its graceful descent through the atmosphere, it encounters something quite remarkable. The layers of air it passes through are like invisible neighborhoods, each with its own character and conditions. Near the cloud base where it began its fall, the air might be cool and humid, but as it descends, it may pass through warmer pockets where the temperature rises and the humidity changes. These variations create a constantly shifting environment that our raindrop must navigate like a traveler passing through different climate zones on a very short journey. But here's where the story becomes even more intriguing, because not every raindrop that begins this descent actually makes it to the ground intact. Some droplets encounter patches of very dry air during their fall, and something called virga occurs. The raindrop begins to evaporate as it falls, losing water molecules back to the thirsty atmosphere around it. You've probably seen this phenomenon before, those wispy streaks of precipitation that seem to hang beneath clouds, like ghostly curtains reaching toward the earth, but never quite touching it. These are the trails of raindrops that gave their all to the journey, but couldn't quite complete it, their water returning to vapor form and drifting away to begin the cycle anew somewhere else. For our fortunate raindrop, however, the journey continues, and as it falls, it becomes part of something much larger than itself. It joins a symphony of precipitation, each drop following its own path, but all part of the same grand performance. Some drops fall straight and true, while others get caught in updrafts and downdrafts that send them spiraling through the air like tiny dancers, each one writing its own story against the canvas of the sky. The collective effect is what we experience as rain, that gentle, or sometimes not so gentle percussion against windows, rooftops, and leaves. During its descent, our raindrop also interacts with the world around it in ways both subtle and profound. It may pass through layers of air that contain different gases, picking up trace amounts of atmospheric chemistry that will eventually make their way into soil groundwater and living systems. It becomes a tiny messenger carrying information about the atmosphere through which it has traveled, the temperature fluctuations it has experienced, the particles it has encountered all become part of its molecular story. As our raindrop approaches the lower atmosphere, it begins to encounter more complex air movements near the Earth's surface. The smooth, laminar flow of the upper atmosphere gives way to turbulence created by the landscape. Below, hills and valleys, buildings and forests all create their own patterns of air movement that can push and pull our raindrop in unexpected directions. A drop that began its descent above a forest might find itself blown toward a nearby field, or a raindrop starting above a city might be carried by urban air currents to land in a completely different neighborhood. The final moments of our raindrop's atmospheric journey are perhaps the most dramatic as it approaches the ground. It may encounter one last obstacle, the boundary layer, that thin zone just above the Earth's surface, where the atmosphere meets the solid world below here. The air is often more turbulent, influenced by the heat radiating from sun warmed surfaces, the friction created by vegetation and structures, and the complex interplay of wind patterns. Our raindrop must navigate this final gauntlet of atmospheric conditions before completing its transformation from sky dweller to earth visitor. And then, in a moment that marks both an ending and a beginning, our raindrop makes contact with the world below. Perhaps it lands on a leaf where it will sit like a tiny lens magnifying the green surface beneath it. Or maybe it strikes the surface of a pond, creating concentric ripples that spread outward, carrying the energy of its impact to distant shores. It might land on concrete, where it will join with other droplets to form small streams that flow toward storm drains, or it could find its way into soil, where it will begin an entirely new chapter of its existence. But wherever our raindrop lands, its journey is far from over, because the water cycle is exactly that. A cycle with no true beginning or end. Our raindrop has completed one phase of an eternal dance that has been going on for billions of years, long before humans walked the earth, and will continue long after we're gone. The same water molecules that make up our raindrop have been part of ancient oceans, have fallen as snow on prehistoric mountains, have been absorbed by dinosaurs, and have risen as vapor from primordial swamps. If our raindrop lands on soil, it may be absorbed by plant roots and become part of a tree's circulatory system, traveling up through the trunk to the leaves, where it might once again evaporate and return to the atmosphere, or it could percolate down through layers of earth, becoming part of groundwater that flows slowly through underground channels, perhaps eventually emerging from a spring miles away, and years later. If it lands in a stream or river, it begins a journey back toward the ocean, following waterways that have carved their paths through the landscape over countless centuries. Should our raindrop land on a roof, it might flow into gutters and storm systems that channel it toward treatment plants, where it will be cleaned and purified before being distributed through pipes to homes and businesses, becoming part of the human water cycle that parallels the natural one. Or perhaps it lands on a mountain peak where it might freeze and become part of a glacier, remaining solid for decades or even centuries before eventually melting and continuing its liquid journey. The remarkable thing about our raindrop story is that it illustrates something profound about the interconnectedness of our world. The water that falls from the sky today has been part of countless other systems and cycles. It has nourished plants and animals, has carved canyons and filled lakes, has been part of the very blood and cells of living creatures throughout history. Our single raindrop is thus a thread in the vast tapestry of Earth's water system, connecting distant places and distant times in ways we're only beginning to understand. Scientists estimate that a single drop of water might spend anywhere from 9 days to several thousand years, completing one full cycle through evaporation, condensation, and precipitation. But the journey is rarely straightforward. Water might evaporate from the ocean, condense into clouds, and fall as rain, only to be absorbed by a plant and released again through transpiration before falling once more somewhere else entirely. Or it might join a river flow to the sea and remain there for years before evaporating again. Each path unique, each timing different. As our raindrop settles into its new temporary home, whether in soil stream or storm drain, it carries with it the memory of its atmospheric adventure. Encoded in its molecular structure are traces of the journey it has taken, the altitude it reached, the temperature changes it experienced, the particles it encountered along the way. Modern science can even read some of these stories using sophisticated instruments to analyze the isotopic composition of rainwater and determine where it originated, how long it spent in the atmosphere, and what conditions it encountered during its journey. But perhaps the most beautiful aspect of our raindrop story is how it reminds us that we are all part of the same vast system. The water that falls as rain today might tomorrow become part of a morning cup of tea, might nourish a garden, might flow through rivers toward the sea, and eventually rise again as vapor to form new clouds and new raindrops. The boundaries we draw between sky and earth, between one place and another, between past and future, become beautifully blurred when we follow the journey of water through its endless cycle. And so, as our raindrop begins, whatever comes next in its journey, whether seeping into soil, flowing toward the sea, or evaporating back into the atmosphere, we're reminded that this is not really an ending, but simply another beginning, another chapter in a story that has no final page. Our raindrop will continue its travels through the Earth's systems, changing form and location, but never truly disappearing, always part of the great circulation that connects all life on our blue planet. The next time you see rain falling outside your window or feel drops on your skin during a gentle shower, remember that each drop carries with it this incredible story of transformation and travel, each one a tiny ambassador from the sky, bringing news of distant places and atmospheric adventures. Each one a reminder that we live in a world where the very air we breathe and the water we drink are constantly moving, cycling, transforming, connecting us to places we've never been and times we've never known. And in this endless circulation, our raindrop becomes part of something even more extraordinary, the intricate web of life itself. Because water isn't just a passive traveler moving through the atmosphere and across the landscape. It's the very foundation upon which all living things depend. Every plant, every animal, every microscopic organism relies on this precious substance that falls so casually from the sky. When our raindrop lands on a leaf, it doesn't simply sit there like a tiny crystal ornament. Instead, it begins an intimate dance with the living world around it. The leaf surface isn't smooth as it might appear to our eyes, but rather a complex landscape of microscopic hills and valleys dotted with tiny pores called stomata. These natural gateways open and close throughout the day, regulating the flow of gases and water vapor between the plant and the atmosphere. Our raindrop might be absorbed through these openings, beginning a journey through the plant's vascular system that rivals any adventure story. Inside the plant, our raindrop joins a remarkable transportation network that would make any city planner envious through tiny tubes called xylem. It travels upward from root to leaf, carried by forces that seem to defy gravity itself. The process, called transpiration, creates a gentle suction that pulls water molecules up through the plant's stem like an incredibly efficient biological elevator system. Our raindrop might find itself rising through the trunk of a mighty oak, traveling dozens of feet upward to reach the very tips of the highest branches. But the plant doesn't simply use our raindrop as a passenger. Instead, it becomes an integral part of the plant's very existence. Water molecules are essential components in photosynthesis, that miraculous process by which plants capture sunlight and transform it into chemical energy. Our raindrop might find its molecules being split apart, their hydrogen atoms joining with carbon dioxide from the air to create sugar, while oxygen is released back into the atmosphere as a gift to all breathing creatures. This is where our raindrop's story becomes deeply personal, because the oxygen released by that plant might be the very oxygen you breathe in your next breath. The connection between the raindrop that began its journey as vapor above a distant ocean and the air filling your lungs right now is direct and immediate. We are all participants in this grand circulation, not merely observers, but active partners in the dance of water and life. Should our raindrop choose a different path and seep into the soil, it enters an underground world every bit as complex and fascinating as the atmosphere it recently left behind. Soil isn't simply dirt, as we might casually think of it, but rather a living ecosystem teeming with microorganisms, fungi, bacteria, and countless tiny creatures all working together to create the foundation for terrestrial life. Our raindrop becomes part of the subterranean community, mixing with nutrients, dissolved minerals, and organic matter to create the rich solution that feeds plant roots. In the soil, our raindrop might encounter earthworms, those humble engineers of the underground world, as they tunnel through the earth. They create channels that help our raindrop penetrate deeper into the soil profile. These natural irrigation systems allow water to reach plant roots more effectively, while also preventing erosion and helping to store water for drier periods. The worm's digestive process also enriches the soil, mixing organic matter with mineral particles to create the fertile medium in which new life can flourish. But the underground journey of our raindrop can take many different paths, depending on the type of soil it encounters. In sandy soils, water moves quickly downward through large pore spaces between grains. Our raindrop might find itself traveling rapidly toward underground water tables or emerging from hillsides as natural springs in clay rich soils. However, the journey is much slower. The tiny spaces between clay particles hold water tightly, creating a reservoir that plants can draw upon during dry spells. Sometimes our raindrops underground adventure leads to groundwater systems, vast underground rivers, and lakes that flow slowly through porous rock formations. This hidden water world spans continents, with some underground rivers flowing for hundreds of miles beneath the surface. Our raindrop might join an aquifer system that has been accumulating water for thousands of years, becoming part of a slow moving underground ocean that supplies wells and springs across entire regions. The temperature underground remains relatively constant compared to the wild swings of atmospheric conditions. Our raindrop finds itself in a stable environment where the seasonal changes that drove its formation in the clouds above seem like distant memories. Yet even here, change is constant as groundwater flows through different rock formations. It picks up dissolved minerals that give it distinctive chemical signatures. The limestone caves carved by patient water over millions of years. The mineral rich springs that bubble up from deep underground all tell stories of water's incredible power to shape the very bones of the earth. If our raindrop's underground journey leads it to emerge at a spring, it once again sees daylight after what might have been months or even years of subterranean travel. The water bubbling up from springs often carries with it the history of its underground adventure, dissolved minerals that give it unique flavors and properties, trace elements that speak of the geological formations through which it has passed. Springs have been sacred places for human cultures throughout history, and our raindrop emerging from the earth carries with it something of that ancient mystery. From springs, our raindrop might join streams that grow into rivers, and the pace of its journey changes dramatically from the slow, patient flow of groundwater to the dynamic, rushing world of surface water. Here it becomes part of a transportation system that has shaped human civilization for thousands of years. Rivers are the highways of the natural world, carrying not just water, but sediments, nutrients, and yes, countless raindrops on their journey back toward the sea. In rivers, our raindrop experiences the full power of flowing water, the way streams carve valleys and canyons, the way floods reshape landscapes, the way water always finds its way downhill, following the path of least resistance, yet creating its own path in the process. The river becomes a storyteller, carrying tales from its entire watershed, the mountain snows that melt in spring, the forest streams that contribute their flow, the agricultural lands that both give to and take from the river's bounty. As our raindrop flows downstream, it might pass through wetlands, those remarkable ecosystems that serve as nature's water treatment plants. Marshes and swamps act like giant sponges, absorbing excess water during floods and releasing it slowly during dry periods. The plants in wetlands are particularly efficient at filtering out pollutants and excess nutrients, making the water cleaner as it flows through these natural systems. Our raindrop might spend weeks or months in a wetland, becoming part of the complex food web that supports countless species of birds, fish, amphibians, and other wildlife. Eventually, if our raindrop follows the river to its conclusion, it arrives back at the sea where its journey began. The mouth of a river where fresh water meets salt water is one of nature's most dynamic environments. Estuaries are incredibly productive ecosystems where the nutrients carried by rivers mix with the salt water of the ocean, creating rich feeding grounds for marine life. Our raindrop has now completed a full circle from ocean to sky to earth and back to ocean. But even this apparent ending is just another beginning. Back in the ocean, our raindrop mixes with the vast body of salt water that covers most of our planet's surface. The ocean is constantly in motion, driven by winds, temperature differences, and the rotation of the Earth itself. Our raindrop might join the Gulf Stream and travel thousands of miles, warming the shores of distant continents, or it might sink into the deep ocean currents that circulate slowly through the abyssal depths, taking centuries to complete their circulation. In the ocean, our raindrop becomes part of an even grander system, the global circulation of water that connects all the world's seas and oceans currents carry water molecules across entire ocean basins, mixing the contributions of rivers from every continent, the Amazon rainforest, the Sahara Desert, the Himalayan glaciers, all contribute their water to this vast mixing bowl that surrounds our continents. But the ocean is far from a passive reservoir. It's a dynamic system, constantly exchanging water with the atmosphere through evaporation. The sun's energy striking the ocean's surface sends countless water molecules, including perhaps our raindrop, back into the atmosphere as invisible vapor, ready to begin another cycle through the sky. The rate of this exchange is staggering, with the equivalent of the entire atmosphere's water content cycling through evaporation and precipitation every 10 days. As our raindrop evaporates from the ocean's surface and rises once again into the atmosphere, it carries with it traces of its recent adventures, the journey through soil and plants, through rivers and wetlands, through the underground world of groundwater systems. All of these experiences have left their mark in subtle ways that scientists are only beginning to understand. Isotopic signatures, chemical traces, molecular memories of the places water has been, and the processes it has experienced. Now airborne once again, our raindrop begins to encounter the complex systems of atmospheric circulation that will determine where it travels next. Trade winds carry moisture from tropical oceans toward the continents. Jet streams transport water vapor across vast distances at high altitudes. Monsoon systems create seasonal patterns of rainfall that have shaped entire cultures and civilizations. Our raindrop becomes part of these grand atmospheric rivers, streams of water vapor that flow through the sky carrying moisture from ocean to land. The scale of these atmospheric systems is breathtaking. A single weather front might transport more water than all the rivers on Earth. Combined, our raindrop riding within these aerial currents becomes part of storm systems that can span entire continents, hurricanes that draw their power from the evaporation of ocean water cyclones that bring life giving rain to drought stricken regions, atmospheric rivers that deliver the snowpack that feeds rivers throughout the dry season. And as our raindrop travels through these atmospheric systems, it begins to interact with human activities in ways both subtle and profound. The cities below modify local weather patterns, creating urban heat islands that affect precipitation. The forests and farms change the amount of water vapor entering the atmosphere through transpiration. The reservoirs and irrigation systems alter the natural flow of water through watersheds. Our raindrop's journey is increasingly intertwined with human civilization. Climate change adds another layer of complexity to our raindrop's story. As global temperatures rise, the atmosphere can hold more water vapor, intensifying the water cycle. In some regions, while creating drought in others, our raindrop might find itself part of more intense storms or longer dry periods. The patterns that have governed water circulation for thousands of years are shifting, and our raindrop becomes both a witness to and participant in these changes. Yet, through all these modifications and disruptions, the fundamental story remains the same. Water continues its endless circulation, connecting sky and earth, connecting distant places and distant times, connecting all living things in an intricate web of interdependence. Our raindrop serves as a reminder that we are all part of this larger system, that the boundaries we draw between natural and human systems are often artificial constructs that don't reflect the deeper connections that bind us all together. And so our raindrop's journey continues not as a linear story with a clear beginning, middle, and end, but as part of an eternal circulation that has no true starting point and no final destination. It's a story that began billions of years ago when water first appeared on our planet, and it will continue long into the future. As long as the sun shines and the earth turns, our raindrop is both ancient and eternally young, both a individual traveler and part of something infinitely larger than itself. The beauty of following our raindrop's journey lies not just in understanding the mechanics of the water cycle, but in recognizing our own place within this grand circulation. We are made mostly of water ourselves, the same water that falls as rain, that flows in rivers, that rises as vapor from the oceans. Our bodies are temporary vessels for water molecules that have traveled the world. Our tears, our sweat, the very blood flowing through our veins, all part of the same circulation that carries our raindrop through its endless adventures. Perhaps that's the most profound realization of all, that our raindrop's story is also our story. We are not separate from the water cycle, but intimately woven into its very fabric. When we drink a glass of water, we're consuming molecules that might have fallen as snow on ancient mountains or bubbled up from deep underground springs. When we exhale water vapor with each breath, we're contributing to the atmospheric moisture that will someday condense into new clouds and new raindrops. This connection becomes even more remarkable when we consider the timescales involved. Some of the water molecules in our bodies might have been part of the very first rains that fell on Earth. Billions of years ago, they could have been locked in ice during the great ice ages flowed through the rivers that carved the Grand Canyon, or been part of the primordial oceans where life itself first began to stir. Our raindrop carries within its molecular structure the memory of deep time connecting us to the vast sweep of Earth's history. But the story doesn't end with these grand geological timescales, because our raindrop is also intimately connected to the immediate rhythms of life around us. When it falls on a garden, it might be absorbed by tomato plants and become part of the fruit that graces someone's dinner table when it lands in a forest. It could be taken up by the roots of mighty trees and released through their leaves during the process of transpiration, helping to cool the air and create the oxygen we breathe. In urban environments, our raindrop faces different adventures. It might flow down storm drains and through complex treatment systems before being cleaned and distributed through municipal water supplies, becoming part of the intricate infrastructure that sustains modern life, or it could land on green roofs and rain gardens, specially designed to capture and filter stormwater, mimicking natural processes in the heart of the city. These human innovations work in partnership with natural systems, creating hybrid landscapes where our raindrop can continue its journey while serving multiple purposes. The seasonal rhythms of our planet add another dimension to our raindrops' adventures. In winter, it might freeze into snowflakes, each one a unique crystalline sculpture formed as water vapor condenses directly into ice around microscopic particles in the frigid upper atmosphere. These ice crystals grow into the familiar six sided shapes we associate with snow, each one following mathematical patterns that seem almost too perfect to be natural, yet emerge from the simple physics of water molecules arranging themselves in the most stable configuration. As snow, our raindrop becomes part of the white blanket that covers mountains and valleys, transforming landscapes into winter wonderlands. But even in its frozen state, the journey continues. Snowflakes accumulate into snowpacks that act as natural reservoirs, storing water through the cold months and releasing it gradually as temperatures warm. The spring melt feeds rivers and streams, creating the seasonal floods that have shaped ecosystems and human civilizations for thousands of years. In high mountain regions, our raindrop might become part of glaciers, those slow moving rivers of ice that carve valleys and transport enormous quantities of water across vast timescales. Glacial ice can preserve water molecules for hundreds or even thousands of years, creating a kind of frozen library of atmospheric conditions from ages past. Scientists can read the history of climate change in ice cores extracted from glaciers, finding trapped bubbles of ancient air and layers of snow that fell during different historical periods. When glaciers eventually melt, they release water that carries stories from the distant past. Our raindrop emerging from glacial ice brings with it chemical signatures from the atmosphere of centuries ago, connecting the present moment to times when the world was very different. The retreat of glaciers in our warming world means that ancient water is being released back into the active water cycle, carrying with it both the memory of past climates and the evidence of current changes. But our raindrops' frozen adventures aren't limited to snow and ice. In the upper atmosphere, it might encounter conditions so cold that it forms part of cirrus clouds. Those wispy high altitude formations made entirely of ice crystals. These clouds play a crucial role in Earth's climate system, reflecting some sunlight back to space, while also trapping heat radiating from the Earth's surface. Our raindrop, as part of these high flying ice clouds, becomes a participant in the complex energy balance that regulates our planet's temperature. The transition between ice and liquid water creates some of nature's most spectacular displays. When our raindrop falls through layers of atmosphere with different temperatures, it might freeze and thaw multiple times, creating sleet or freezing rain. These ice storms transform ordinary landscapes into crystal palaces, coating every surface with a thin layer of ice that turns the world into a glittering wonderland, while also demonstrating the incredible power of water in its various forms. Returning to liquid form, our raindrop might find itself part of the morning dew that collects on grass and flowers overnight. This gentle precipitation, occurs when surfaces cool below the dew point, causing water vapor in the air to condense directly onto them without ever forming clouds. The dewdrops that sparkle in the early morning sunlight are like tiny lenses, each one focusing light and creating miniature rainbows that last only until the warming sun causes them to evaporate back into the atmosphere. The formation of dew represents one of the most intimate connections between our raindrop and the living world because many plants and animals depend on this gentle moisture to survive in arid regions. Dew can provide a significant portion of the water needed by desert plants and small animals. The spider webs decorated with dewdrops at dawn aren't just beautiful, they're efficient water collection systems that some spiders depend on for their survival. Fog represents another fascinating phase of our raindrops' atmospheric adventures. When conditions are just right, water droplets remain suspended in the air at ground level, creating those mysterious veils that transform familiar landscapes into ethereal dreamscapes. Our raindrop, as part of a fog bank, becomes a temporary resident of the boundary between earth and sky, neither fully airborne nor settled on the ground, but suspended in a liminal space that seems to belong to both worlds. Coastal regions experience unique forms of fog as warm, moist air moves over cooler ocean surfaces, creating dense banks of water droplets that roll inland like slow moving waves. Our raindrop riding within these fog systems might travel for miles across land, providing moisture to coastal forests through a process called fog drip, where droplets condense on leaves and drip to the ground. Some ecosystems, particularly the coastal redwood forests of California, depend heavily on this fog moisture to survive the dry summer months. The redwood trees themselves become active participants in our raindrops story. Their enormous height allows them to capture moisture directly from fog banks, while their transpiration creates localized humidity that encourages more fog formation. It's a beautiful example of how living systems and atmospheric processes work together, creating feedback loops that sustain both the forest and the fog that nourishes it. In tropical regions, our raindrop might become part of the daily rhythm of convective storms as the sun heats the land surface throughout the day. Warm, moist air rises, creating towering cumulus clouds that build into afternoon thunderstorms. These daily cycles of evaporation and precipitation create some of the most biodiverse ecosystems on Earth. As our raindrop participates in these tropical rhythms, it becomes part of the engine that drives rainforest productivity. The Amazon rainforest represents perhaps the most remarkable example of how our raindrop becomes part of larger atmospheric systems. The trees of the Amazon release so much water vapor through transpiration that they create their own weather patterns. Moisture evaporated from the Atlantic Ocean falls as rain in the eastern Amazon, is absorbed by plants, and released again, creating precipitation that travels westward across the continent. In this way, water that began as ocean evaporation can fall as rain multiple times as it moves across the rainforest. This phenomenon, sometimes called the flying river, demonstrates how our raindrop becomes part of continental scale atmospheric circulation systems. The moisture transported by the Amazon's transpiration provides rainfall for agricultural regions thousands of miles away, connecting the health of tropical forests to the productivity of distant farmlands. Our raindrop thus becomes a messenger carrying life. giving moisture across vast distances and linking ecosystems that might seem completely separate. But the story of our raindrop also intersects with human activities in increasingly complex ways as global temperatures rise due to climate change. The behavior of water in the atmosphere is changing. Our raindrop might find itself part of more intense storms, as warmer air can hold more moisture, leading to heavier precipitation events. When storms do occur alternately, it might experience longer periods as atmospheric vapor, as changing weather patterns alter the timing and location of precipitation. These changes have profound implications for both natural ecosystems and human societies. Our raindrop falling in different patterns and intensities affects agriculture, water supplies, flood control, and countless other aspects of modern life. The story of a single raindrop thus becomes intertwined with some of the most pressing challenges facing our world today, reminding us that climate change isn't an abstract concept, but a very real alteration of the fundamental processes that sustain life on Earth. Yet, even as we recognize these challenges, the story of our raindrop also offers hope because it reminds us of the incredible resilience and adaptability of natural systems. Water has been cycling through Earth's systems for billions of years, surviving ice ages, volcanic eruptions, massive changes in atmospheric composition, and countless other upheavals. The same processes that carry our raindrop through its journey today have persisted through all of Earth's history, adapting to changing conditions while maintaining the essential circulation that makes life possible. Our raindrop's story also highlights the importance of protecting the natural systems that maintain the water cycle. Healthy forests, wetlands, rivers, and watersheds all play crucial roles in ensuring that water continues to move through the environment in ways that support both natural ecosystems and human communities. When we protect these systems, we're not just preserving individual species or habitats, but maintaining the larger circulation patterns that our raindrop depends on for its endless journey. The interconnectedness revealed by following our raindrop's path suggests that environmental protection isn't just about preserving beautiful places for their own sake, but about maintaining the fundamental processes that sustain all life actions taken in one part of the world can affect water cycles thousands of miles away. Just as our raindrop connects distant places and times, our environmental choices connect us to people and ecosystems across the globe. And so, as our raindrop continues its eternal circulation, moving from atmosphere to earth, to rivers to oceans, and back again, it serves as a reminder of both our connection to the natural world and our responsibility to protect the systems that sustain us all. Its journey is our journey. Its story is part of our story, and its future is intimately connected to the choices we make today about how we treat the water that falls from the sky and flows through our world. The next time rain taps gently against your window, or you feel drops on your skin during a shower, remember that each drop carries within it this incredible story of transformation, travel, and connection. Each one a tiny ambassador from the vast circulation that connects all life on Earth, each one a reminder that we live in a world where everything is connected, where the boundaries between sky and earth, between one place and another, between past and future, are beautifully blurred by the endless dance of water through its many forms and countless adventures. And as you drift toward sleep tonight, Perhaps you'll dream of clouds forming high above distant oceans of water, vapor rising invisibly into the atmosphere, of droplets growing and merging in the darkness of storms, of the gentle fall of rain on leaves and soil and streams. For in your dreams, as in your waking life, you are part of the same circulation, your breath adding moisture to the air. Your body is a temporary home for water molecules that have traveled the world and will continue traveling long after you've returned them to the endless cycle that connects us all to the sky and the earth and to each other in ways both seen and unseen, both understood and still mysterious. The beauty of our raindrops story lies not just in its individual journey, but in how it weaves together with countless other stories unfolding simultaneously across our planet. Right now, as you listen to these words, millions upon millions of raindrops are beginning their own atmospheric adventures, each one following a unique path, yet all participating in the same grand circulation that has sustained life on Earth for eons. Imagine, if you will, the sheer scale of this watery symphony. At any given moment, approximately 10 to the power of 15 raindrops are suspended in clouds around the globe. That's a number so large it defies comprehension, more raindrops than there are stars in our galaxy, each one a tiny protagonist in its own epic tale of transformation and travel, yet all connected by the invisible threads of atmospheric circulation and the fundamental physics of water. But here's where the story becomes even more enchanting, because our raindrop doesn't travel alone through its atmospheric journey. It becomes part of weather systems that span continents and influence the lives of millions of people. A single storm system might carry water vapor from tropical oceans across thousands of miles, delivering life giving precipitation to regions that would otherwise be parched deserts. Our raindrop riding within these vast atmospheric rivers becomes a participant in the grand theater of weather that shapes our daily lives. Consider the monsoon systems that bring seasonal rains to billions of people across Asia. These massive circulation patterns transport enormous quantities of moisture from the Indian Ocean inland, creating the seasonal floods that have sustained agricultural civilizations for thousands of years. Our raindrop caught up in a monsoon system becomes part of a phenomenon so vast and powerful that it influences the rhythm of life across entire continents, the timing of planting and harvesting, the flow of great rivers, the very survival of ecosystems that have evolved to depend on these predictable seasonal patterns. In North America, our raindrop might become part of the atmospheric river systems that carry moisture from the Pacific Ocean across the western United States. These narrow corridors of concentrated water vapor, sometimes called Pineapple Express systems, can transport more water than the Mississippi River carries in liquid form. When these atmospheric rivers encounter mountain ranges, they're forced upward, cooling rapidly and releasing their moisture as precipitation that feeds the snowpack in the Sierra Nevada and Cascade Mountains. The snowpack created by our raindrop and its countless companions serves as a natural reservoir, storing water through the winter months and releasing it gradually during the spring melt. This stored water feeds rivers that provide drinking water for major cities, irrigation for vast agricultural valleys, and habitat for salmon and other wildlife that depend on the seasonal rhythms of flowing water. Our raindrop frozen into a snowflake on a high mountain peak becomes part of this critical water storage system that sustains millions of people and countless ecosystems. But the story doesn't end with these regional systems, because our raindrop also participates in global circulation patterns that connect weather systems across the entire planet. The El Nino and La Nina phenomena in the Pacific Ocean create temperature variations that influence precipitation patterns worldwide. Our raindrop might find itself part of altered storm tracks that bring unusual drought to some regions while causing flooding in others. These global teleconnections demonstrate how water vapor in the atmosphere serves as a medium for transferring energy and influence across vast distances. The jet streams, those high altitude rivers of fast moving air, also play a crucial role in our raindrops' atmospheric adventures. These powerful currents can carry weather systems and their associated moisture across entire ocean basins. In a matter of days, our raindrop caught in a jet stream might travel from the coast of Japan to the Pacific Northwest faster than most commercial aircraft, creating connections between distant places that would seem impossible if we only considered surface transportation. As our raindrop participates in these global atmospheric circulations, it becomes part of the Earth's climate system, a complex web of interactions between atmosphere, ocean, land surface, and ice that regulates our planet's temperature and makes life as we know it possible. The water cycle isn't just about the movement of H2O molecules through different phases and locations. It's about the transport of energy, the regulation of temperature, the creation of weather patterns that sustain the delicate balance of conditions that allow life to flourish. The role of clouds in this system cannot be overstated, and our raindrop suspended within a cloud becomes part of one of the most important components of Earth's climate regulation. Clouds reflect incoming solar radiation back to space, helping to cool the planet. But they also trap heat, radiating from the Earth's surface, creating a warming effect. The balance between these two influences depends on cloud type, altitude, and the size of the droplets within them. Our raindrop, as part of a cloud, becomes a participant in this delicate balancing act that helps maintain Earth's habitability. High altitude cirrus clouds, made of ice crystals, including perhaps our raindrop in frozen form, tend to have a net warming effect because they're relatively transparent to incoming sunlight, but very effective at trapping outgoing heat radiation. Low altitude cumulus clouds, made of liquid water droplets like our raindrop in its liquid phase, tend to have a cooling effect because they're highly reflective to incoming solar radiation. The height at which our raindrop condenses and the form it takes thus influence the planet's energy balance in subtle but important ways. The formation of precipitation itself plays a crucial role in atmospheric circulation because when water vapor condenses into liquid droplets or ice crystals, it releases latent heat, the energy that was stored when the water originally evaporated. This heat release warms the surrounding air, causing it to rise and creating the vertical air movements that drive weather systems. Our raindrops' condensation from vapor to liquid thus contributes to the very atmospheric circulation patterns that carry it on its journey. Tropical cyclones, hurricanes, and typhoons represent some of the most dramatic examples of how this latent heat release drives atmospheric circulation. These massive storm systems are essentially heat engines powered by the evaporation of warm ocean water and the subsequent condensation of that water vapor in the atmosphere. Our raindrop, if it becomes part of a hurricane system, participates in one of nature's most powerful demonstrations of the energy contained within the water cycle. The spiral structure of hurricanes, the eye wall, the rain bands all result from the complex interplay between evaporation, condensation, and the rotation of the earth. But our raindrops' atmospheric adventures aren't limited to these dramatic weather events. It also participates in the quieter, more subtle processes that shape our daily experience of weather. The formation of morning mist as the earth cools overnight, the gradual buildup of cumulus clouds during a sunny afternoon, the gentle drizzle that might fall for hours from a layer of stratus clouds. Each of these phenomena involves our raindrop and its companions moving through the atmosphere in response to temperature, pressure, and humidity changes that occur on scales both grand and intimate. The diurnal cycle, the daily rhythm of heating and cooling that occurs as the earth rotates relative to the sun, creates regular patterns of atmospheric circulation that our raindrop experiences throughout its journey. During the day, solar heating creates thermal updrafts that carry moisture upward, leading to cloud formation and afternoon precipitation. During the night, radiative cooling can cause water vapor to condense as dew or fog our raindrop, thus becomes part of the daily breathing of the atmosphere, the regular expansion and contraction of air masses that creates local weather patterns. Urban areas create their own unique atmospheric environments that influence our raindrops' journey. Cities absorb and retain heat differently than rural areas, creating urban heat islands that can intensify local precipitation. The concrete and asphalt surfaces common in cities don't absorb water like natural soils, so precipitation runs off more quickly, creating flash flood risks. The tall buildings and complex urban geometry create turbulence and wind patterns that can dramatically alter how our raindrop moves through the lower atmosphere. Green infrastructure initiatives in cities are creating new pathways for our raindrops' urban adventures. Green roofs, rain gardens, and constructed wetlands provide spaces where precipitation can be absorbed and filtered naturally, rather than rushing directly into storm drainage systems. These urban ecological systems work with natural processes to manage stormwater while also providing habitat for wildlife and improving air quality. Our raindrop landing in an urban rain garden becomes part of a small scale ecosystem that demonstrates how human design can work in harmony with natural water cycles. The concept of watershed management recognizes that our raindrop's journey doesn't end when it hits the ground, but continues as it flows across landscapes towards streams, rivers, and ultimately the ocean. Everything that happens within a watershed, the forests that are preserved or cut, the agricultural practices that are employed, the urban development that occurs, all influences the quality and quantity of water that flows through the system. Our raindrop becomes a carrier of information about all these land use decisions, transporting nutrients, sediments, pollutants, and other dissolved substances as it moves through the landscape. Riparian zones, the areas along streams and rivers, play particularly important roles in our raindrop's terrestrial journey. These transition zones between aquatic and terrestrial ecosystems act as filters and buffers, modifying the chemistry of water as it flows past vegetation in riparian areas, can remove excess nutrients from agricultural runoff, preventing water pollution downstream. The roots of trees and shrubs help stabilize stream banks, preventing erosion that would cloud the water with sediments. Our raindrop passing through a healthy riparian zone emerges cleaner and clearer than when it entered. Wetlands represent some of the most productive and ecologically important stops along our raindrop's journey. These areas where water remains at or near the surface for extended periods create unique ecosystems that support incredible biodiversity while also providing crucial ecosystem services. Wetlands act as natural flood control systems, absorbing excess water during periods of heavy precipitation and releasing it slowly during drier times. They filter pollutants from water, improve water quality, and provide habitat for countless species of plants, animals, and microorganisms. The plants that dominate wetland ecosystems have evolved remarkable adaptations to life in waterlogged conditions. Many have specialized root systems that can function in oxygen poor environments, while others have developed unique strategies for dealing with fluctuating water levels. Our raindrop entering a wetland becomes part of a complex ecological web where every component has evolved to make the most of the water that flows through the system. Prairie potholes, small seasonal wetlands scattered across the Great Plains of North America, demonstrate how our raindrop can become part of continental scale ecological processes. These temporary pools fill with spring snowmelt and rainfall, providing crucial breeding habitat for millions of waterfowl that migrate along ancient flyways stretching from the Arctic to South America. Our raindrop collected in a prairie pothole might evaporate into the atmosphere and eventually fall again thousands of miles away, connecting distant ecosystems through the invisible threads of atmospheric circulation. The timing of our raindrop's arrival can be just as important as the quantity of water it provides. Many ecosystems have evolved to depend on predictable, seasonal patterns of precipitation. The Mediterranean climate regions of the world, with their wet winters and dry summers, support unique plant communities that have adapted to this seasonal rhythm. Our raindrop falling during the brief winter rainy season becomes part of the annual pulse of growth that sustains these drought adapted ecosystems through the long dry months. Desert ecosystems present some of the most dramatic examples of how life adapts to infrequent precipitation when our raindrop finally falls in an arid region after perhaps months or even years of drought. It triggers remarkable transformations, desert wildflowers that have remained dormant, as seeds suddenly germinate, bloom, and complete their entire life cycles in the brief window of moisture availability. Desert animals emerge from underground burrows to take advantage of the temporary abundance of water and food. The phenomenon of desert blooms, where vast areas of seemingly barren landscape suddenly burst into colorful displays of wildflowers following rare rainfall events, demonstrates the incredible resilience and patience of life in arid environments. Our raindrop becomes the catalyst for these brief, spectacular displays that can attract visitors from around the world to witness the desert's hidden beauty revealed. Cacti and other succulent plants have evolved sophisticated strategies for capturing and storing our raindrop. When it falls in desert regions, their specialized root systems can quickly absorb water from brief precipitation events, while their modified leaves and stems store that water for extended periods. Some cacti can expand significantly when they absorb water, then gradually shrink as they use their stored moisture. During drought periods, our raindrop might remain within a desert plant, for months or even years before being released back into the atmosphere through transpiration. The concept of water harvesting, both by natural systems and human technologies, demonstrates how valuable our raindrop becomes in arid environments. Traditional societies in dry regions developed sophisticated techniques for capturing and storing precipitation, including terraced hillsides that slow runoff and allow more water to soak into the soil, underground cisterns that collect and store rainwater, and fog nets that capture moisture directly from the atmosphere. Modern water harvesting technologies build on these traditional approaches, using materials and designs that can more efficiently capture and store precipitation. Green building techniques incorporate rainwater collection systems that can supply significant portions of a building's water needs while reducing the burden on municipal water supplies. Our raindrop collected from a rooftop and stored in a rain barrel becomes part of a decentralized water management system that works with natural processes rather than against them. Permaculture design principles recognize that our raindrop's journey across the landscape can be guided and enhanced through thoughtful planning. Contour planning swales, berms, and other landscape modifications can slow the movement of water across sloped terrain, allowing more precipitation to soak into the soil rather than running off as erosion, causing surface flow. These techniques not only conserve water, but also build soil fertility and support more diverse plant communities. The restoration of degraded landscapes often focuses on reestablishing healthy water cycles that have been disrupted by human activities. Overgrazing, poor agricultural practices, and urban development can all alter how our raindrop moves through the environment, creating conditions where precipitation runs off quickly rather than soaking into the soil. Restoration projects work to rebuild the natural infrastructure that supports water infiltration and storage, helping to heal damaged ecosystems while also improving water quality and flood control. Fire plays a complex role in many ecosystems and influences how our raindrop interacts with the landscape. Wildfires can dramatically alter soil properties, affecting how quickly water soaks in versus running off the surface. Some ecosystems have evolved to depend on periodic fires to maintain their health, and these fire adapted systems have also evolved strategies for quickly recovering after our raindrop begins to fall on burned landscapes. The first rains after a fire can trigger massive germination events, as seeds that have been waiting for the combination of fire and water finally sprout. But fire can also create challenges for our raindrop's journey. Burned soils sometimes become hydrophobic, repelling water rather than absorbing it. This can lead to increased runoff and erosion, following fires creating floods and mudslides when our raindrop falls on steep burned slopes. The management of fire-prone landscapes increasingly recognizes these connections between fire, water, and ecosystem health. Agricultural systems represent some of the most intensive human modifications of our raindrop's natural journey. Farming practices determine whether precipitation soaks into the soil or runs off, whether it carries nutrients or pollutants, whether it supports biodiversity or creates environmental problems. Sustainable agricultural techniques work with natural water cycles, using cover crops, contour planting, and integrated pest management to create farming systems that enhance rather than degrade the landscapes through which our raindrop travels. The ancient practice of terracing steep hillsides for agriculture demonstrates how human ingenuity can work with gravity and water flow to create productive landscapes that also prevent erosion. These stepped agricultural systems, found in mountain regions around the world, capture our raindrop and hold it on the landscape, allowing it to soak into the soil and support crop growth while preventing the destructive runoff that can occur on steep, unmodified slopes. No-till farming practices recognize that soil structure plays a crucial role in determining how our raindrop interacts with agricultural land by minimizing soil disturbance and maintaining organic matter. Farmers can create soil conditions that absorb and hold more water, reducing both drought stress and flood risks. The networks of fungal threads and plant roots in healthy soil create pathways that help our raindrop penetrate deep into the soil profile, where it can be stored and gradually released to plants during dry periods. Crop rotation and polyculture practices also influence our raindrop's agricultural journey. Different plants have different water needs and rooting patterns. By growing diverse crops in rotation or combination, farmers can make more efficient use of available precipitation while also building soil health and supporting beneficial insects and other wildlife. Our raindrop falling on a diverse agricultural landscape becomes part of a more resilient and sustainable food production system. The integration of trees into agricultural landscapes through agroforestry practices creates complex three-dimensional systems that interact with our raindrop in multiple ways. Trees provide windbreaks that reduce evaporation from crop fields. Their roots help improve soil structure and water infiltration. Their canopies intercept precipitation and reduce erosion from heavy rainfall events. The fallen leaves create mulch that helps retain soil moisture between precipitation events. And so, our raindrop's journey through human modified landscapes reveals both the challenges and opportunities that arise when natural water cycles intersect with human activities. We have the power to work with these natural processes, creating systems that enhance water quality support, biodiversity, and provide for human needs, or we can work against them, creating problems that ultimately affect both environmental health and human well being. The choice is ours, and it's reflected in every decision we make about how we design our cities, manage our farms, protect our forests, and interact with the natural systems that support all life on Earth. Our raindrop serves as a reminder that these choices matter not just for abstract environmental reasons, but because they directly influence the fundamental processes that sustain us all. As our raindrop continues its eternal circulation, it carries with it the consequences of all these human decisions. The health of the ecosystems. It passes through the quality of the soil. It encounters the cleanliness of the water. It joins, all reflect the cumulative impact of countless individual choices made by people like us who may never see the distant places where our local actions ultimately have their effects. But that's the beauty and the responsibility revealed by following our raindrop's journey. We are all connected through the circulation of water that knows no political boundaries, recognizes no property lines, and flows according to the ancient laws of physics and chemistry that have governed our planet since long before humans appeared on the scene. Our raindrop reminds us that in a world where everything is connected, what we do in one place inevitably affects what happens in another, and as the night grows deeper and your eyelids grow heavier. Perhaps you'll find yourself drifting along with our raindrop as it continues its endless journey through the water cycle that connects us all to the sky and the earth and to each other in ways both seen and unseen, both understood and mysteriously beautiful sleep. Well knowing that even as you rest, the great circulation continues its ancient dance, carrying water and wonder through the darkness toward another day. And now, as we near the end of our gentle journey with this remarkable raindrop, perhaps it's time to reflect on what we've discovered together. We've followed a single molecule of water from its invisible beginnings as vapor rising from distant seas through its transformation in the towering architecture of clouds, through its graceful descent as precipitation, and into its myriad adventures across the landscapes of our planet. Each phase of this journey has revealed layer upon layer of connection and complexity that transforms something as simple as a raindrop into a thread in the vast tapestry of life itself. But what strikes me most profoundly about our raindrop's story is how it serves as a perfect metaphor for the interconnectedness that defines our world. In an age when we often feel isolated, when the boundaries between nations seem to grow stronger and the divisions between people appear to deepen, our humble raindrop whispers a different truth. It tells us that separation is largely an illusion, that the water falling outside your window tonight has traveled the world, that the breath you exhale contributes to clouds that will bring rain to distant shores, that we are all participants in the same grand circulation, whether we realize it or not. The mathematics of this connection are staggering. Scientists estimate that the water molecules in your body right now have each been through the water cycle countless times. They've been part of ancient oceans, fallen as snow on mountains that no longer exist, flowed through rivers that carved canyons over millions of years, been absorbed by forests that covered continents in ages past. The very substance of your being carries within it the history of our planet, written in the arrangement of hydrogen and oxygen atoms that have witnessed the rise and fall of countless civilizations. This perspective transforms how we might think about time and permanence, what seems solid and lasting. The mountains, the continents, even the ocean basins are all temporary features on a planet where water has been the one constant, cycling endlessly through its various forms and phases. Our raindrop has seen ice ages come and go, has been present during mass extinctions and remarkable recoveries, has participated in the gradual processes that have shaped and reshaped the face of our world. There's something deeply comforting about this continuity in a universe where everything eventually changes and passes away. The water cycle represents a kind of eternal return, a promise that transformation is not destruction, but simply another form of existence. Our raindrop will never truly disappear. It will only change form and location, becoming part of new stories, new adventures, new connections across the vast web of life. The indigenous peoples of many cultures understood this truth intuitively. Their stories and ceremonies often reflect a deep appreciation for water as a sacred substance that connects all living things. They recognized that to pollute water was to pollute ourselves, that to waste water was to waste the very essence of life itself. These traditional understandings are finding new relevance as modern science reveals the intricate ways that human activities are altering the global water cycle. Climate change represents perhaps the greatest disruption to the water cycle that our planet has experienced since the end of the last ice age. As temperatures rise, the atmosphere can hold more water vapor, leading to more intense precipitation events in some regions, while other areas experience prolonged droughts. The delicate balance that has sustained ecosystems and human civilizations for thousands of years is shifting in ways that we're only beginning to understand. Our raindrop's journey is thus not just a story of natural processes, but also a mirror reflecting our own impact on the planet, the quality of the water that falls from the sky, the timing of precipitation, events, the intensity of storms all bear the subtle signatures of human influence. We have become participants in the water cycle in ways that our ancestors could never have imagined affecting atmospheric circulation patterns through our greenhouse gas emissions, altering local weather through our land use decisions, modifying the chemistry of precipitation through our industrial activities. Yet, this same interconnectedness that makes us responsible for changes to the water cycle also offers hope because it means that positive actions can have far reaching beneficial effects. When we protect a forest, we're not just preserving trees, but maintaining the transpiration processes that contribute moisture to the atmosphere. When we restore a wetland, we're not just creating habitat for wildlife, but rebuilding natural infrastructure that filters water and moderates floods. When we reduce our carbon emissions, we're helping to stabilize the climate systems that govern precipitation patterns around the world. The story of our raindrop thus becomes a call to stewardship, reminding us that we are not separate from the natural world, but deeply embedded within it. Our choices about energy use and transportation, food consumption, and countless other daily decisions all ripple outward through the interconnected systems that our raindrop travels through. We are all weather makers in the sense that our collective actions influence the atmospheric processes that determine where and when rain falls. But perhaps the most beautiful lesson from our raindrop's journey is how it reveals the poetry hidden within science. The water cycle, which we might dismiss as a simple elementary school concept about evaporation and precipitation, turns out to be one of the most elegant and complex systems on our planet, involving quantum mechanics, atmospheric physics, soil chemistry, plant biology, and countless other fields of study. Yet at its heart, it remains accessible to anyone who has ever watched rain fall or marveled at the formation of clouds. This accessibility is part of what makes water such a perfect teacher. It surrounds us constantly, yet never stops surprising us with its properties and behaviors. We think we understand it because it's so familiar, yet it continues to reveal new secrets to scientists who study its molecular structure, its role in climate systems, its interactions with living organisms. The more we learn about water, the more remarkable it becomes, and the more we realize how much we still don't know. The phase transitions that our raindrop undergoes, the shift from vapor to liquid to ice and back again, represent some of the most fundamental processes in physics. Yet they create some of the most beautiful phenomena in nature. The delicate structure of snowflakes, the towering architecture of thunderclouds, the gentle mist that rises from a lake at dawn, all emerge from the simple fact that water molecules can arrange themselves in different ways under different conditions. These transformations happen according to precise physical laws, yet they produce infinite variations. No two snowflakes are exactly alike, No two clouds form in precisely the same way. No two raindrops follow identical paths from sky to earth. This combination of underlying order and endless diversity seems to capture something essential about the nature of existence itself. The way that simple rules can generate limitless complexity, the way that patterns repeat, yet never quite the same way twice. As our raindrop continues its eternal circulation, it serves as a reminder that change and continuity are not opposites, but partners in the dance of existence. Everything flows, as the ancient philosopher Heraclitus observed, yet the patterns of flow themselves persist. The river is never the same river, yet it remains recognizably a river. Our raindrop is never the same collection of molecules, yet it participates in the same essential processes that have operated for billions of years. This paradox of change within continuity offers a different way of thinking about permanence and loss. What matters is not the persistence of individual forms, but the continuation of processes and relationships. Our raindrop will eventually evaporate or flow away, but the connections it has made, the ecosystems it has nourished, the stories it has been part of, all continue to ripple outward through the world in ways both seen and unseen. The water cycle thus becomes a metaphor for resilience, showing us how systems can maintain their essential character while constantly adapting to changing conditions. Forests may burn, but if the water cycle continues to function, new forests will grow, rivers may change course. But water continues to flow toward the sea. Species may go extinct, but life itself persists as long as the fundamental processes that support it remain intact. This resilience is not infinite. However, it depends on maintaining the complex web of relationships that allow natural systems to function when too many connections are broken, when too many processes are disrupted. The whole system can shift into a different state that may not support the life forms that evolved under previous conditions. Our raindrop's journey thus carries within it both hope and warning hope because it demonstrates the incredible capacity of natural systems to heal and regenerate, warning because it shows how everything is connected and how disruptions in one part of the system can cascade through the whole. The indigenous concept of thinking 7 generations ahead, considering how our actions today will affect our descendants. 7 generations in the future takes on new meaning when viewed through the lens of our raindrop's journey. The water we use today, the emissions we produce, the landscapes we modify, all will influence the atmospheric and hydrological processes that will determine what kind of world we leave for future generations. Our raindrop serves as an ambassador from that future, carrying messages about the health of the systems that will determine whether that future is abundant or impoverished, whether it offers stability or chaos, whether it supports flourishing life or struggling survival. The quality of the water that falls from tomorrow's skies will reflect the choices we make today about how we treat the planet that we share. But our raindrop also carries messages from the deep past, reminding us that we are part of a story much larger than our individual lives or even our species. The water falling tonight has been part of the story of life on Earth since the very beginning. It has witnessed the first stirrings of life in primordial oceans, the colonization of land by plants and animals, the rise and fall of countless species, including perhaps someday our own. This deep time perspective can be both humbling and liberating. humbling because it reminds us of our small place in the vast sweep of geological and evolutionary time, liberating because it suggests that the processes that have sustained life through countless challenges and transformations will continue long after we're gone. Our individual actions matter, but they matter as part of something much larger than ourselves. The story of our raindrop thus offers a different kind of immortality, not the preservation of individual identity, but participation in something eternal, the circulation of water that connects all life, the great breathing of the planet as moisture rises and falls, the ancient rhythms that have pulsed through the Earth's systems since water first appeared on our world. As you listen to these words, perhaps rain is beginning to fall outside your window, or perhaps the sky is clear and starlit either way. Invisible water vapor surrounds you right now, carrying within its molecular structure the memory of countless journeys. The same processes that we've followed in our raindrops adventure are happening all around you all the time. You are breathing water, vapor that will someday condense into clouds. You are drinking water that has traveled the world. You are part of the circulation, whether you think about it or not. This participation is not metaphorical, but literal. The boundary between your body and the environment is permeable to water. You are constantly exchanging moisture with the air around you through your breath, through your skin, through the countless invisible processes that maintain your life. You are not a separate entity observing the water cycle from the outside, but an active participant in its endless dance. The same forces that lift our raindrop into the atmosphere, that guide its journey through clouds, that bring it back to earth, also flow through you. The energy from the sun that drives evaporation also powers the chemical reactions in your cells. The gravity that pulls raindrops toward the ground also shapes the circulation of fluids in your body. The temperature gradients that create weather patterns also regulate the processes that keep you alive. Understanding this connection transforms how we might think about health and healing. Recognizing that we are part of the water cycle suggests that our well being is intimately connected to the health of the larger systems of which we are part. Polluted water, polluted air, disrupted climate patterns all affect us, not as external threats, but as disruptions to the very processes that constitute our being. This holistic perspective is finding new expression in fields like ecopsychology, which explores the connections between human mental health and environmental medicine, which studies how environmental factors affect human physiology. These approaches recognize what our raindrops journey has shown us, that the boundaries between self and world, between human health and planetary health, are far more porous than we usually imagine. The therapeutic value of water has been recognized by cultures around the world for thousands of years. Hot springs, healing baths, ocean therapy, forest bathing. These practices intuitively recognize what science is now beginning to understand, that our bodies and minds respond to water in ways that go far beyond simple hydration. We are drawn to water because we are water, because the rhythms of waves and rain and flowing streams echo the rhythms of our own internal circulation. The sound of rain falling, the sight of sunlight on water, the feel of mist on skin all trigger responses that seem to operate below the level of conscious thought, connecting us to something deeper than language or logic. Perhaps these responses evolved because our ancestors who paid attention to water, who felt connected to its cycles, were more likely to survive and thrive in environments where water was both life giving and potentially dangerous. Today, when many of us live in environments where water appears magically from taps and disappears mysteriously down drains, we may have lost some of that intuitive connection to the water cycle, but the connection itself remains as strong as ever we can choose to become more aware of it, more grateful for it, more protective of the systems that maintain it. Our raindrops journey offers us a roadmap for rediscovering that awareness by following water through its transformations, by tracing its connections across the landscape, by recognizing our own participation in its circulation. We can begin to see ourselves as part of something larger and more beautiful than we might have imagined. We can begin to understand that caring for water is caring for ourselves, that protecting watersheds is protecting our own health, that working to stabilize the climate is working to ensure that future generations will have access to the same miraculous circulation that has sustained life on Earth for billions of years. And so, as our gentle journey with this remarkable raindrop draws toward its close, we're left not with an ending, but with an invitation to see the world through water's eyes, to recognize the connections that bind us to every living thing, to participate consciously and gratefully in the circulation that makes all life possible. Our raindrop will continue its travels long after these words fade from memory, but the awareness it has awakened, the connections it has revealed, can remain with us, transforming how we see the world and our place within it. The next time you see rain falling or mist rising or dew forming on morning grass, remember that you are witnessing one of the most ancient and essential processes on our planet. Remember that each drop carries within it stories of distant places and deep time. Remember that you too are part of this story, that your breath and your body and your very existence depend on the same circulation that lifts water from the seas and returns it as gentle rain. And perhaps as you drift toward sleep tonight, you'll carry with you some sense of the wonder that surrounds us, always the miracle of water rising and falling, the gift of precipitation, the blessing of the circulation that connects sky and earth, and all the life that flourishes in between. For in the end, our raindrop's journey is also our journey, its story part of our story, its endless circulation, a reminder that we too are part of something eternal, something beautiful, something worthy of our deepest gratitude and most careful protection. Sleep well, knowing that even as you rest, the great circulation continues its ancient dance, carrying water and wonder through the darkness toward another day when rain will fall and rivers will flow and the eternal story will continue with new chapters written by countless raindrops, each one carrying its own adventures, its own connections, its own small but essential part in the vast symphony of water that makes our blue planet home. And as the night settles deeper around us and your breathing begins to slow, perhaps you can feel yourself becoming part of this very circulation we've been following, your breath releasing tiny droplets of water vapor into the air around you. Each exhalation is a small contribution to the atmospheric moisture that will someday form new clouds, new raindrops, new stories of transformation and travel. There's something profoundly peaceful about recognizing this connection, about understanding that even in sleep, you remain part of the great breathing of the planet. The gentle exchange of moisture between your body and the world around you, a quiet participation in the same processes that lifted our raindrop from the sea and carried it through towering clouds and brought it back to earth as precipitation. Your own body is a landscape through which water flows, following pathways as intricate and purposeful as any river system. The circulation of blood carrying dissolved nutrients and oxygen, the lymphatic system filtering and cleansing the countless cellular processes that depend on water's unique properties to dissolve, transport, and transform the very chemistry of life. You are not just observing the water cycle, you are the water cycle in microcosm. And perhaps that's the most beautiful realization of all, that the boundary between inner and outer, between self and world, dissolves when we follow water's journey. Closely enough, the same H2O molecules that make up the morning dew might soon be part of your morning tea. The rain that falls on distant mountains might eventually flow from your kitchen tap, the water vapor you exhale tonight might condense in clouds above some far off ocean, connecting your breath to weather systems you'll never see. This recognition transforms something as simple as drinking a glass of water into an act of communion with the entire planet. Every sip connects you to glacial streams and underground springs, to morning mist and afternoon showers, to the vast oceanic circulation that regulates our climate and sustains all life. You become part of the story, not just a reader of it, a participant in the endless dance, not just an observer from the sidelines. There's comfort in this continuity, in knowing that the water flowing through your body tonight has been part of countless other stories before yours and will continue its journey long after you've returned it to the great circulation. Perhaps it will nourish a tree that hasn't yet been planted, or fall as snow on mountains that haven't yet been formed, or rise as vapor from oceans that will exist in climates we can hardly imagine. The time scales of water's journey dwarf our human experience. Yet somehow we remain intimately connected to processes that began billions of years ago and will continue for billions more. Our raindrop carries within its molecular structure a kind of immortality, not the preservation of individual identity, but participation in something that transcends any single lifetime, any single story, any single species. And as you settle deeper into rest, perhaps you can feel yourself joining this timeless flow, letting go of the boundaries that separate you from the world around you, becoming like water itself, fluid, adaptable, patient, finding your way through whatever landscapes await, whether they be the familiar territories of daily life or the strange new worlds that dreams create. Your sleeping breath will add moisture to the night air, contributing to the humidity that might condense as dew on morning grass or rise to join the water vapor that will someday form new clouds. The circulation continues even as consciousness fades, the great dance of evaporation and precipitation flowing through you and around you and beyond you, connecting this moment to moments yet unborn. In traditional cultures, water was often seen as a teacher, a source of wisdom about how to live in harmony with the natural world. Its patience in wearing away stone, its persistence in finding a path, its ability to nourish life wherever it flows. Water shows us how gentleness and consistency can accomplish what force and haste cannot, how flexibility and adaptability can overcome the most formidable obstacles. Our raindrop's journey embodies these lessons, showing us how something small and seemingly insignificant can be part of movements that reshape continents, how individual drops can merge into streams that carve canyons and nourish civilizations, how what appears to be lost to evaporation returns transformed as precipitation in distant places, the humility of water, its willingness to flow downhill to fill the lowest places, to take the shape of whatever container holds it, becomes a model for how we might move through our own lives. The generosity of water, too, offers inspiration. Our raindrop asks nothing for its service, yet it gives freely of itself, nourishing plants and animals, filling rivers and lakes, moderating temperatures, and creating the conditions that allow life to flourish. It doesn't discriminate between deserving and undeserving recipients, but falls equally on just and unjust alike, offering its gifts without condition or reservation. This unconditional giving extends to us as well, we who depend entirely on water's circulation for our survival, yet rarely pause to acknowledge this dependence or express gratitude for the countless gifts it provides. The air we breathe humid with life giving moisture, the food we eat grown with precipitation's blessing, the very blood flowing through our veins, borrowing water temporarily for its essential work as you drift towards sleep tonight. Perhaps you can carry with you some sense of this gratitude and appreciation for the miraculous ordinariness of water's presence in your life, from the glass beside your bed to the moisture in your breath to the gentle rhythm of rain that might be falling outside your window. Each drop a small miracle, each moment of circulation a gift beyond measure. The story of our raindrop thus becomes more than an account of atmospheric and hydrological processes. It becomes a meditation on connection and interdependence, on the way individual elements combine to create something larger than themselves, on the beauty that emerges when we pay close attention to what we usually take for granted. Science and poetry merge in water's story, revealing the elegance hidden within the everyday, the profound connections underlying the mundane. Our raindrop serves as a bridge between the quantifiable and the mysterious, between what we can measure and what we can only wonder at, between the mechanics of molecular behavior and the magic of a world where water falls from the sky like a daily blessing. And perhaps that's what we most need to remember in times when the world seems fractured and disconnected, that beneath all our human divisions and differences, we share the same water, breathe the same moisture, participate in the same ancient circulation that has sustained life on Earth since long before our species appeared and will continue long after we're gone. Our raindrop reminds us that separation is largely an illusion, that the boundaries we draw between nations and peoples, between past and future, between self and world, are permeable like cell membranes, allowing the essential substances of life to flow freely across whatever barriers we might imagine exist. In this recognition lies both humility and humility, because it reminds us of our dependence on forces far greater than ourselves. Hope, because it suggests that the same processes that have sustained life through countless challenges and transformations continue to operate, that the circulation that nourishes us also connects us, that we are part of something resilient and enduring and beautiful. The gentle sound of rain against windows, the sight of mist rising from a lake at dawn, the feel of snowflakes melting on your tongue all become invitations to remember this connection, to step outside the narrow boundaries of individual experience and feel yourself part of the vast breathing of the planet, part of the circulation that makes all life possible. And so, as our journey with this remarkable raindrop draws to its gentle close, we're left not with conclusions, but with wonder, not with answers, but with deeper questions, not with endings, but with the recognition that every ending is also a beginning, that every completion of a cycle marks the start of something new. Our raindrop will continue its travels, rising and falling, transforming and flowing long after these words have faded from memory. But the awareness it has awakened can remain with us, changing how we see the world and our place within it, helping us recognize the extraordinary within the ordinary, the sacred within the scientific, the eternal within the everyday. Tomorrow, when you see clouds forming, or feel rain beginning to fall, or notice dew sparkling on morning grass, you might remember this journey and smile, knowing that you're witnessing the continuation of a story that began billions of years ago and will continue for billions more. A story of which you are an inseparable part, a circulation of which you are an essential element, a dance in which your every breath is a step. The water cycle asks nothing of us but our participation, offers nothing but the gift of life itself, expects nothing but our presence, provides nothing but the foundation for everything we are and everything we hope to become in return. Perhaps all it asks is that we remember, that we notice, that we remain grateful for the miracle of moisture falling from the sky and the endless circulation that connects us all. And as you drift now toward sleep and dreams, may you carry with you some sense of this connection, this wonder, this gratitude. May your rest be as gentle as morning mist, as refreshing as spring rain, as peaceful as a still lake reflecting stars. And may you wake tomorrow with renewed appreciation for the water that surrounds you, sustains you, and flows through you, connecting your life to all life in the endless, beautiful circulation that makes our blue planet home. Sleep well, fellow traveler, knowing that even as you rest, the great dance continues, water rising and falling, connecting and nourishing, transforming and returning in the eternal rhythm that holds us all. And may your dreams be filled with the gentle sound of rain and the quiet knowledge that you too are part of the story, part of the circulation, part of the miracle that falls so softly from the sky. Good night,